Hey guys, today I'll show you how Grounding DINO and the segment anything model or SAM can work together to extract a specific object from the image based on the user input text. Here you can see two example images here. In the first image here you can see a person is sitting on a chair, and if the user input text is person and the chair, then Grounding DINO model will return bounding box information of these two objects inside the image. And using this bounding box information, segment anything model will generate marks for this object, and finally we can extract this person and the chair from the original image. Similarly, here you can see another original image, and if the user input text is mobile and the cup, then Grounding DINO model will return bounding box information of this detected object, and finally segment anything model or SAM will generate marks for this detected object, and using these marks we will extract the detected object mobile and cup from the original image. Now I will show you step by step implementation how we can extract specific or detected object from the image using this Grounding DINO and the segment anything model. So before going to implementation, I would like to give you some basic idea how Grounding DINO and the segment anything model works. Here you can see the Grounding DINO model. Basically this model takes two input. One is the original image and another is the user text. If the user text is person and the horse, and if we send this original image to Grounding DINO model, basically Grounding DINO model will search this horse and the person inside this original image, and if it is found inside the image, then Grounding DINO model will return two bounding box information of this detected object, and then we'll send this bounding box information or bounding box coordinate to the SAM model or segment anything model. Then segment anything model will generate marks for this detected object. Here you can see the example. If we send this original image to segment anything model and the point coordinates of the bounding box of two detected object to the segment anything model, then SAM model will generate two separate marks of this detected object. Basically using these two marks, we can extract the detected object from the image. So now we can start step by step implementation in Google Colab. If you wish to know detail about the Grounding DINO and the segment anything model, you can watch my two videos from my channel on Grounding DINO and the segment anything model. So let's get started. Now we can go for the implementation how Grounding DINO and segment anything model or SAM can work together to extract two or more objects from the image based on your input text or input classes. So first of all, we just need to change the runtime from here. You can click here and set it to GPU. NVIDIA SMI, this command basically will check the GPU status. Here you can see Tesla T4 GPU is assigned. From here basically we will get the current working directory using get cwd command and store it inside the home variable. Sorry, here you can see the home directory. Basically you can click here, and this is the basically your the current working directory. If you install anything or if you download anything, then it will show inside here. Then you need to clone the Grounding DINO from this link, and then we need to move this Grounding DINO directory and need to install all of the things. So just execute. It will take a little bit time. You can see here the Grounding DINO directory will be created inside my home directory. Here you can see Grounding DINO directory created. Now we need to install segment anything model SAM from this git link. Also we need to install some important packages like torch vision and the supervision. So one by one we can execute. Then you need to install torch vision and the supervision. After installing supervision, it may require to restart the runtime. So here you can see the restart runtime is required, so you just need to click here. As we have restart runtime and we have used this home variable again, that's why you just need to get this current working directory again. So you just need to execute this line again. Now we can move forward. So here you can see inside the home directory, this is my home directory here, and inside home directory I have created weights directory, and inside the weights directory I have downloaded the Grounding DINO model weight. From this git link I have downloaded this model weight of the Grounding DINO, and then we need to download the model weight of the segment anything model. Here you can see we all of you know that there are three types of segment anything model. One is VIT Ace heavy model. Here you can see VIT Ace, and also another two model VIT L large model and VIT B is the beta model. So here inside the weights directory, I will download the grounding dynamo model weight and the segment analytic model bit is heavy model weight inside this weights directory. So you just need to execute this. Here weights directory will be created, and inside this weights directory grounding dino and the segment analytic model weights will be downloaded. So if we refresh from here, you can refresh, you can see here the weights directory is created, and inside the weights directory grounding dino model weights is downloaded. So now we'll download the model weight of the segment analytic model. If we refresh, then we can see here the same bit is heavy model weights downloaded. Here we just assign the device, so definitely we will get the CUDA 0. Here you can see CUDA 0. To initialize grounding dino, basically we need two variables. One is model config path and another is the model checkpoint path. So first of all, we need to assign these two variables, grounding dino config path and the grounding dino checkpoint path. So from where we can get this grounding dino config path and the checkpoint path, I am showing you. Basically checkpoint path is the model weight path. So from here you just click the copy path and paste inside the model checkpoint path, grounding dino checkpoint path. And another is the grounding dino config path. For getting this config path, we just need to click this grounding dino directory, and here you can see another grounding dino directory and then config directory, and inside config directory you will get two python file. So basically this one is swinty. This python file is the grounding dino config path. So we just need to copy this path and paste it inside this variable. So basically this is the idea how we can initialize the grounding dino model. So we just need to execute. Basically here I have used opencv to read the image, and I will send this image to grounding dino model, and also I will send the classes name, or I can send the text prompt, and based on these classes or text prompt, grounding dino model will return the bounding boxes and some other information like the confidence and the class id. So we need to upload image inside my current working directory. I'll upload this image. We can rename this image, it will easy for the operations. So here we just need to change one. Here basically I have read the image using opencv, and then we change the color from bgr to rgb, and we have keep a bgr image copy inside the original image, and here I have resized all of this image. Here you can see the original image size was too large, that's why I have resized this image to 1024 by 1024. Now we can plot this image using supervision. Basically supervision is used for image visualization, also it is used for image annotation. So here you can see the image. So from this image we can identify this app and the mobile. So how grounding dino will work, let's check. Basically here grounding dino model will take two major inputs. One is the classes name, here you can see the mobile and the cup, and another is the image. So I'll send this image and the class name, and the grounding dino model will return bounding box information if this mobile and cup present inside the image, and also it will return some other information like the confidence and the class id. So we can check it. So grounding dino model is working with this image and the class name. If this class is present inside the image, then it will return the bounding boxes and some other information. So here you can see two bounding boxes, one bounding boxes and another bounding boxes here, and also you can see the confidence and the class id. 1 and 0. 0 is mobile and 1 is the cup. Now we need to extract this bounding box information, because we need to send this bounding box information to the segment analytic model, and segment analytic model will generate the marks over detected object. Here basically I have print detection.xyxy. So here you can see detections. Inside the xyxy will get two bounding boxes, and inside these detected boxes I have kept two bounding box information, and inside the class ID I have kept the class ID. Here is the bounding boxes, and type is numpy array, and here you can see the class ID. Now you can annotate the detected object, that means mobile and cup, using the supervision. Here you can see scene is the image bezier, detection is the detections, skip level is true, and here is the labels is the class ID. So now you can plot this. Finally detected class 0 is the mobile, and class 1 is the cup. So in this way basically we can draw fast the bounding boxes using the supervision. And now I will send this bounding box information to segment anything model for getting the marks of this segmented part, these two objects. So here is the basically initialization of the SAM model. So SAM model type is vit ace, and this is the model checkpoint path. So basically this is the model checkpoint SAM vit ace. So from here we can just get this path, and here you can see the model type and the checkpoint path is required to initialize the SAM model. Here I have assigned a marks predictor variable to predict marks based on the bounding box information written by the grounding DINO model. So first I will initialize the SAM model, and then I will send the bounding box information written by the grounding DINO model to segment anything model, and also we need to send the image, and based on this information segment anything model will return the marks of this segmented object. So we need to initialize this SAM model. As two bounding box detected by the grounding DINO model, that's why I have initialized a loop here, and inside the loop I have sent one by one this bounding box information to the segment anything model. Here is the segment anything model, and segment anything model will return the marks. Basically here you can see box information, and here you can see the image. So based on this image and this box, segment anything model will return the marks, and then we will plot these marks later. So we can execute this. Also we have annotated the image based on the marks returned by the segment anything model. So basically this is the code. Here you can see. If you wish to know detail about the segment anything model, you can check my another video from my channel. Basically segment anything model can generate marks in three ways. One is automatic marks generator. In this way basically segment anything model SAM can return marks for all of the segmented part of the image. And another two ways, one is marks generated by the bounding box information, and another is marks generated by the point coordinates. So here I have used basically bounding box information, as the grounding DINO model return bounding box information based on the class's name or based on the text prompt. So here I have used the bounding box to generate marks by SAM model. So you can execute this. So first of all we can plot the annotated image. Here you can see image annotation based on these segmented marks generated by the SAM model. Here you can see the mark shape. So you just need to change this shape to convert these marks into the image. So here basically I have used basically this code is used to convert all of these generated marks by segment anything model to the bezier image. So how you can do this? Here you can see I have used the transpose to reshape the marks, and then I have used this line, and here I have used this line to convert these marks into the numpy array image, and here I have just convert this image from gray to bezier. As the marks generated by the segment anything model is 2D binary image, so definitely it will be the gray image. So we just need to convert it to gray to bezier. From here you can see the previous mark shapes and the present marks shape. That means this marks converted into 3D bezier image. First I can draw all of the marks here. Here you can see this is the first marks. Here you can see the marks for the cup, and here you can see the marks for the mobile. Basically now it converted into the image. Basically here I have joined all of the marks using bitwise OR operation generated by the segment anything model. These two marks will be joined together using this bitwise OR operation, and here you can see inside the single image we have joined these two marks together. Now I will perform here bitwise AND operation between this segmented image, that means the joint marks and the image bezier, and then we'll plot this image. So what will happen? Here you can see we have successfully extracted these two objects, and all other part of the image is now black. Here you can see the mobile, and here you can see the cup. So if we erase all of this black background, then we can finally extract. So basically here is the code. You can see here I have replaced all of this 0 pixel using this 255 pixel. So definitely black pixel will be removed here. Here you can see I have successfully extracted the cup and the mobile. So here finally you can check all three images side by side. Here you can see this was the original image, and this is the annotated image, and this is the segmented image, and we have successfully extracted the segmented part of the image based on my input text. So this is all about the segment anything model and the grounding dyno, how it can extract the object from the image based on my the input text or input classes. I can show you for some other image. I have uploaded another image, another two image, and I will show you the result of these two images. So now I can read image 2 here. You can also perform this operation for your own image. You can upload this image and you can execute this code, and I will give you this Colab notebook inside my video description box, so you can use this link to execute for your own image. So here you can see the image, horse and the person. So we just need to change the class name here, person. Here you can horse. Then successfully we can draw the class ID 0. This is the 1. So this is the person is 0. So we don't need to again initialize the same model. We just need to execute this to extract the marks based on the bounding box information written by the grounding dyno model. So we just need to execute this to get the marks based on the bounding box information written by the grounding dyno model. Here you can see person, horse, 2 marks is generated successfully. We can annotate this. Here you can see the marks, and here basically converted all of these marks into the bezier image. Here you can see the shape of the marks, and finally it converted into 3D bezier image. Now you can plot this, all of the marks. Here you can see 2 marks, and here basically we have joined these 2 marks together into the segmented image. Here you can see here we'll perform bitwise AND operation between this segmented image and the bezier image. Basically this is the segmented image, so we'll get this image with black background. Then we just need to convert this black pixel into the white pixel. So this is the basic idea. Then we can plot side by side all of this image. Here you can see successfully we have extracted the object based on the text prompt. This is the original image, this is annotated, this is the segmented image. Rename this image to 3, and I can show you for image 3. We just need to put it here 3. We can plot it. Here you can see a person sitting on a chair. So we can send person and the chair. Here you just need to change chair to bounding box detected by the grounding dyno model, and we just keep this bounding box information inside the detected boxes variable, and we can plot this annotated image. Here you can see successfully detected the person and the chair. Here you can see. So don't need to initialize again the same model. We just send this bounding box written by the grounding dyno model to segment anything model. So inside this loop I have sent one by one this bounding box information segment anything model, and segment anything model will return 2D marks for each of the bounding box information. So here you can see person and the chair, and this is the marks shape here. So you can draw this. Here you can see successfully annotated by the return marks of segment anything model, and we just need to convert these marks into BGR image. So here is the basically perform three lines of code. One is the transpose, and this one inside this loop. So here you can see successfully converted this shape into the BGR image. We can plot these two marks here separately. Here you can see this is the person and the share marks, and now if we join this mask together using bitwise OR operation, here you can see this is the image. Now I will perform bitwise AND operation between original image BGR, and the segmented image. Basically this is the segmented image. So if we perform this bitwise AND operation, then we'll get this image with black background. Then we just need to remove this black background by this line of code, and here you can see extracted the image. And if we plot this side by side, all of these three images, here you can see this is the original image, this is the original image, and the annotated image, and the segmented image. So basically in this way you can also extract a specific part of the image based on your input classes or the text by grounding DINO and the segment anything model. So thank you very much. If you wish to interest to get my next video, please subscribe my channel. Thank you all.